Okay, we're going to move on to structures. So a structure is generally a collection of data. So you could have records. Records consist of different entities, which could be fields. So it's a collection of data or a collection of objects. So a typical example would be the NFL example. So those of you maybe do follow football. So we have struct, NFL team. So each NFL team would have a team name. So I'm using character array here. Of course, you could use a string. Then each team would have a coach. Each team would have a quarterback. So here our struct has 3 character arrays and 1 int. So I've actually changed this. So 1 int. An int would be Super Bowl. So how many Super Bowls have they won or maybe gone to? So that's a basic representation of a structure. A basic representation of a structure. So if we move on, so here we're going to instantiate an object or a struct. So remember earlier on we had NFL is a struct name, NFL team. So we're going to say NFL team, our object is going to be Seahawks. And then we're generally just copying, or you could assign values into any of these objects. So here we have Seahawks.team name. Remember team name here. Then we have Seahawks.coach, Seahawks.quarterback. That's how you can access or assign values into those objects. So once you have defined the struct, you can create as many instances as you like. So here we could have NFL team Broncos on the same thing. We have a coach, quarterback, and number of Super Bowls. So you could continue this. I mean, you don't always need to specify what we saw earlier on. Broncos.team name, Broncos.coach. You can assign data directly into whatever object you've created, the instance name. So it's a quick form of initialization here. So to manipulate structures, we would generally say Seahawks.coach. So you have to specify the name of that instance or the object, and also if you want to assign values. We can create an array of structures. So we can have NFL teams. So remember the array. So here we have 32 teams, and to be able to access each team, it's going to be from 0 through 31. So to access our team, we will say teams and the index number, followed by whatever property or field that we've created within that struct. Questions on that? Does that make sense so far? Okay, so is that enough? So when we continue from the PowerPoint slide, so there's different types of structures, data structures. So we have linear data structure, and we've already used arrays. That is a form of structure. Strings is another one, records, stacks, queues, lists. Linked lists is a fine example, or double linked lists. Non-linear is trees, because they branch out, just like you would see a normal tree. So that's a basic idea of what a struct is. Now we're continuing on to that. How do we write a file? Or how do we write data to a file? So the basic structure of that is going to be using the off stream. So an off stream is basically a pipe, or an out file name is a buffer space that we're creating. File name is going to be the name of the file that you're going to create. That's going to sit in the same folder as your CPP file, or your exe file, should I say, is going to sit in. So offstream indicates the output file stream, and it's going to be used for outputting. So we can enter or update the file. So it's a flat file. It is not a relational database. So in order to read a file, we once again need to create another stream where we're going to throw in the data and be able to access data from that stream. And to use that, we're going to use inFileName. Once again, give it the file name, and we're going to use input-output status, set it to in. Now, if we look at the example, so I'll come back to this, the file input-outputs, but that gives you a basic idea in terms of file input-output. But if we move on to structures, so one thing earlier on that I had missed out was the semicolon at the bottom of the curly brace. So you do need to remember it has to be enclosed in a curly brace at the bottom. So whenever you create a struct, you need to make sure that you close it with a curly brace. So if we go through, find that code. So make sure this is always closed with a semicolon at the end of your struct. So you need to remember that. So if you refer to the example from the tutorial, and I'll put that copy online, see how that works. So basically we have two functions. One is we're going to read from a file, and the other one is we're going to write to a file. And right at the top we generally have two arrays, and it's going to be the make and the model. So in the write to file, we're going to create a stream. We're going to say offstream, our outcar file is going to be our buffer. cars.dat, that could be a txt file. .dat refers to a data file. So we're going to create that, then we're going to go into the do while loop, and we're going to enter the data. And each time we're going to assign whatever we've entered into our outcar file stream or buffer. Finally, when we jump out of that, you basically close it. We're finished with that. And then if we come to the top and we select the next choice we want to read, we then create the if stream, and we make sure we're reading the cars.dat, which should hopefully hold the data. And then we see out the value. So what this does is it actually see out until it reaches the end of file. So it's going to keep throwing data out until it reaches the end of file. So that's all it's doing here. It's testing. There's a condition in car file, the make, the model, the year. It's pulling out, and then it displays that out. So you could actually assign this data into another data structure like a linked list or a B tree, or generally arrays. So based on that, on Wednesday, what I'd like you guys to do, or have tried to have done at least some of it, is to try to do the bank account example. So we're basing it off this example that I've provided. How do you write data to how do you write data to a file, be able to read the data, and be able to display whatever is stored in that. In addition to that, how can you override data? How do you think you can override data? Or how can you add data to an existing list of data? No, without pointers. So we've got nothing to do with pointers. So once you get this, each time you can add data, but it'll overwrite the file. But we don't want to overwrite the existing data, so how would you do that? So that's what I'd like you guys to be working on.